Today we're going over 6.6, which is property of logs. So our learning target today is to condense and expand logarithmic or log functions. You should have done this before, so this isn't new, we're just revisiting it. So we're going to start with the product property, which says that if you have a logarithm with base b and you're multiplying within the argument of the logarithm, another way to write it in expanded form is to use addition. So I'm going to draw this little dotted line through all of these just so that it's clear that this is the condensed form. So when you're asked to condense, you'll condense to a single logarithm, and this over here is the expand form. Now, because logarithms and exponents are inverses of each other, you should make some sort of connection between those two things, exponents. So this is a squared times a to the fifth. And when we're multiplying between the bases, what do we do with the exponents? We add them. Because logs and exponentials are inverses, it's the opposite. You're multiplying here between the arguments, so when you expand, you add them. So here's our example over here. We're multiplying the 3 and the x, so it's going to be log base 2 of 3 plus log base 2 of x. That's expanded notation. All right, quotient property. This says that if you are dividing between a logarithm, the argument, then when you expand it, you are going to subtract. And again, we have something to tie it to from our previous knowledge that if we are if we're dividing between exponents, then we subtract them, right? So the bases are being divided, so we subtract the exponents. So it's very similar for logarithms since they are inverses. So here, this would look like log base 7 of 19 minus log base 7 of x. Next, we have the power property that says if you have log base b of an argument raised to a power, another way to write this is to multiply. So you're going to bring that power down in front of the logarithm and just multiply it by the logarithm. So the exponential equivalent would be something like this. So if you have a to the fourth raised to a power, what do you do with those exponents? You multiply. So that's a similar thing here. So we have log base 5 of 7 to the fourth power. So we're going to take that 4 because it's the power and bring it down. Everything else stays the same except for the 7 now has an exponent of 1. Okay, so there's that. Here's some helpful hints when you're asked to expand. You are always going to write it with plus or minus, and or minus really, because you can have two in the same problem. And no exponents. So exponents are in the condensed form. When it says condensed, this means write it as a single logarithm. Okay, so let's practice with these right now. So this first one says expand each expression. So we know that's what's going on between these two right there is multiplication. So what we're going to do is write two natural logarithms with an addition sign in between them because we're asked to expand it out. Okay, for this one, what you're going to want to do first is because we have that exponent, we're going to bring it down in front. So 2 log base 5 of x, and that's actually all we can do with that one in terms of expanding because there's nothing else to do there. When we move on to C, now we have division. So this is division, and when we have division, it's your little hint that a division sign looks like a minus sign. So we have one value in the numerator and one value in the denominator. So because there's two values, we should have two logarithms. I'm saying that because as we move on, it's going to be helpful to be like, okay, how many logarithms should I have when I expand it? Especially when we get to E and F, even though it says D. Okay, so for this one right here, we are multiplying between those two right there, 64 times x cubed, so that's going to be log base 4 of 64 plus log base 4 of x cubed. And then we're going to have to do two things. First of all, this right here, because 4 and 64 are related by powers, we're going to change this. So this is really 4 to what power equals 64. So this whole thing, logarithms equal exponents, is just 3. So you're going to have to watch out for those. And then this one right here, we have the 3, we're going to bring it down in the front. 3 log base 4 of x. Alright, moving on to the next one. We have a square root in there. So what the heck do we do with that guy? Super easy. We use what we learned earlier in the chapter to rewrite the square root of x as x to the 1/2. So remember, it's power, this is to the first power, over the root. If the root isn't written in math, that is reserved for the square root or degree 2. Alrighty. So now what are we doing? So we have x to the 1/2 over y squared z. So we have 1, 2, 3 variables or 3 values. So I should have 3 logarithms when I expand this. So I have log base 3 of x to the 1/2. That's in the numerator. And then I'm going to subtract, and this is where you have to be careful. Because we have 2 values in the denominator, we have to put it in parentheses. So this is log base 3 of y squared minus log base 3 of z. And we need to clean this up a little bit. And then I'm going to give you guys a trick in just a second. But let's start with this guy because there's a power. Whenever we expand, we won't have powers left up in the argument of the logarithm. So that's just 1/2 log base 3 of x. And then I'm going to distribute this minus sign, and actually I just made a little error here. I want to fix that real quick. You're multiplying between these two, so this should be an addition. I was just kind of skipping a step. So now I'm going to do this and distribute that minus, and then, and only then does it become a minus. Because I think we can handle it, I'm going to go ahead and put this 2 down in front. Minus log base 3 of z. And then I'm going to check to make sure that there's no exponents left in there. There's only one value in each argument, and then I know I'm done. I also am checking to make sure that, like I did over here with 4 to what power is 64, that I can't do that here, but because all of the arguments are variables, you're not going to be able to. One helpful trick is to remember that if it's in the denominator, it automatically will be a minus. Okay, so let's move on to the next problem. It's actually slightly easier than the one we just did. So we have 2 terms in the numerator. If it's in the numerator, it's going to be addition, and then we have another value down in the denominator. So this is going to be, we're multiplying here, and then we're subtracting that guy. So log base 6 of 5 plus, now this one has an exponent. So we're taking a shortcut here than what we did before. If the shortcut is too much for you, don't take the shortcut. Write out log base 6 of x cubed. But I think at this point, since it's the second time you've seen it, it might be better to actually skip a step if you can. I'm going to actually go ahead and erase this so I have more room. It's all correct, I just need more room. So I'm going to write a little smaller. So it's log base 6 of 5 plus 3 log base 6 of x minus, because that y is in the denominator, log base 6 of y. Sometimes students will make the mistake of dropping the base of the logarithm, which completely changes the value, so don't do that. Make sure whatever this base was, you carry that into the expanded notation. Alright, we're ready to flip it over. So now we're going to be condensing, so we're going to be going the other way. So when we go the other way, we need to make sure that whatever is out in front, like this 2, gets pulled up into the exponent, and then this is a multiply, because when you do addition in logarithms and when you condense, it becomes multiply, and we only want one log sign. So this looks like this, log, there's base 10, it's base 10 because there's no 10 written, so we don't have to write anything, of x squared times 5, and then we're just going to clean that up to proper notation, which is to have the number first, or the coefficient first. So log base 5 of x squared. Now we're going on to the next one. So we have log base 7, and so this minus sign gets changed into division, and then this 4 is going to come up in here, and I only write one logarithm. So I'm just going to read this exactly how it says. Log base 7 of 48 divided by, I have the 2 to the 4th power. And again, we're just going to clean that up. Log base 7 of 48 over 16, because 2 to the 4th power is 16. And then log base 7 of 3. 7 to what power is 3? I can't simplify that without using a calculator, so we're good there. That's as simplified as we can be. On to letter C, which says the natural log of 4 plus, so I'm going to change that to a multiply. The number out in front is going to go up, cross out the natural log because you only write it one time when you condense. And then I have another one, which is a minus, so I'm going to change that to division and cancel that out. So what this ends up looking like, if I read through what I've written, is I have the natural log of 4, and then my next thing is times, and I have 3 to the 3rd power, all divided by 12. And then we're going to clean that up. Okay? So that's going to look like this, natural log of 4 times 27 over 12, because we do exponents first. And then when I do that, that's going to equal the natural log of, well, we can either use a calculator, or 4 goes into 12 3 times, and then 27 divided by 3 is 9. So it's the natural log of 9. Alrighty, last condensed problem. We're moving through these nice and quickly. So this one right here, the 2/3, is going to go up into the exponent, and then the minus signs becomes division. The 4 goes up into the exponent of the y, cross out the logarithm because you only write it once. And then over here, the addition becomes multiplication, cross out the logarithm because you only write it once. So what I end up with is log base 5 of x to the 2/3, because that came up, divided by y to the 4th power from this one, and then multiplied by 6. So multiplying fractions, no big problem, top times top over bottom times bottom. So this looks like this. Log base 5 of 6x to the 2/3 over y to the 4th. And if you want to be fancy, which it's always fun to be fancy, you could write this as power over root, so it would look like this. Log base 5 of 6. That 2/3 does not belong to the 6, it only belongs to the x. And then we're taking the cube root, because that's the root, of x squared all over y to the 4th. Ooh, fancy. Alrighty, the last property that we're going to be learning is called the change of base formula, or the change of base property. And it says that we are going to be changing our base to base 10. So or you can change it to e, Really, in the world of math, it can be any base, but we're going to focus on base 10 and base e. And the reason why we're focusing on base 10 or base e is because then we can use the calculator, because the calculator operates out of base 10 or base e. So right here, this is what this says. If you have log of some base and the argument is m, then if you're changing it using the common base, which is base 10, because our number system is base 10, so it's so common, like 10, 100, 1,000, that kind of thing, log base 10 of m divided by log base 10 of your base. So it's always argument over base. And one cool thing to remember is that the base is in the bottom already, and it starts with a b, so it should be in the bottom of a fraction. If you'd like, you can also use e, and if you're using base e, then it would be the natural log, because e is the natural number. So again, same thing though, you take the natural log of the argument over, you're changing the base to the natural log of whatever the base was. Okay, so let's see this in action. So right here, we're going to use natural log for this one, randomly selecting, regular log, we'll use natural log, and regular log, just for fun. If I switch and use regular log, the common log and natural log, I should still be getting the same answer. That's what the change of base formula says. It shouldn't be changing the value of that logarithm. Just a different way to get it. So right here, log base 7 of 52, so it's going to be, if I'm using natural log, I take the natural log of the argument over the natural log of the base. And then I'm going to plug it in my calculator. I'm going to be really careful to put the arguments in parentheses in the calculator, otherwise it's not going to work out for you. And we're going to round to 3 decimal places, and when I do this in the calculator, I get 2.031. Okay, the next one, log base 5 of 154. Base 5 is not in your calculator, so in order to punch it into your calculator, use log of the argument over log of the base, and then you punch it into your calculator and you get 3.130. Then you move on to letter C, log base 2 of -2. So this would be the natural log of -2 over the natural log of 2. This is a trick question, because when you actually plug this into your calculator, you're going to get an error. This is because this is undefined, and the reason why it's undefined is because, first of all, I'm going to do it from a graphing approach. Logarithms take this shape, right? They take this kind of like lowercase r shape. And when you have a -2 in here, it's saying when x is -2, what's your y value? Well, there's no y value there. The algebraic approach to understanding why this is undefined is me asking you 2 to what power equals -2. And we've kind of already talked about this. This can't happen because 2 to the first power is 2, 2 to the second power is 4. These numbers are just going up. 2 to the 0 power is 1. If I do 2 to the -1, I get 1/2. 2 to the -2 is 1/4. So if you look at all these outputs, am I ever getting a negative output? No. So that's why it's undefined. Alrighty, it's okay to do these with fractions. We're using natural log, so natural log of 61 over the natural log of 1/3. Boop, 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 which is -3.742. You're just plugging that into your calculator. And then this last one, it's okay to have the argument be a fraction as well. Log of 1 over 73, so you'll make sure that's all in parentheses in your calculator, just like these guys, all over log of 4. It's pretty straightforward. Log of the argument over log of the base. Plug it into your calculator properly, and we get negative 3.095. And that, my friends, is properties of logarithms.